Okay, so hello everyone. So today will be our final project. So the Lab 14. So since for the class time, some students mentioned the whiteboard is not clear, so I decided to make a new video. Okay, so first of all, um, we have a pre-lab for the final project, but it's not going to be graded. Okay, so it's just for feedback. So try to submit it before Wednesday 2 p.m. So I will try to give you the feedback before end of the Wednesday. So as I mentioned, it's not going to be graded, but I just want to check it. So make sure you are on the right track before you go too far. Okay. And then we have the report for the final project. So the deadline for the report will be August 1st, end of the day. I think it should be this Sunday. Okay, yeah, it's this Sunday, end of the day. Okay, so, and also there is a document called topology. So that's example of the schematic you're going to build for the final project. And also there are a couple introduction video, which are very helpful. Okay, so let's talk about the project. Okay, so this is the block diagram for your project. So this is an equalizer, and the equalizer is inside of the speaker. So uh, when you think about speaker, the speaker have music signal. Okay, so sometimes we only want to hear about the uh, music that have strong bass. Okay, so in that case, we will make the music signal at lower frequency, make the volume larger, and make the music higher at higher frequency, make the sounds smaller. Okay, so that's how the equalizer work. Okay, so this three the circuit inside the equalizer divides the music signal into three different frequency bands. Okay, this is a low pass, this is a mid frequency, and this is a high frequency. Okay, so in that case, when you want to hear the music that have only strong bass, which means you can turn off the uh, frequency for this two band and leave only the strong bass, which is the lower frequency. Similarly, if you only want the higher frequency for the music, you can turn off these two parts and leave only these parts. Okay, so that's how the equalizer work. Then after the equalizer, you have a total volume control. Okay, so by tuning the amplifier in here, you can control the total volume. And after that, you have a power amplifier, which will make the will drive the speaker. And then you have high pass filter and low pass filter to use for two different speaker. So this part is actually you learned this in the lab 10. Okay. And also this part is the actual created part. So in today's lab, we will focus on the equalizer part. Okay. So as I mentioned, this is a block diagram for the equalizer. So this uh, equalizer will divide the frequency into three different bands. So how you can divide the frequency? You will use a filter. Okay, so here is the filter. Here is the low pass filter. You have a band pass filter, and you have a high pass filter. Okay, so filter help you to divide the frequency according to their cutoff frequency. Okay, and then after each filter, you have a volume control, so that you can control the volume at different frequency. So after each pass, the signal will combined by the summing amplifier, and you have a total volume control by use the summing amplifier. Okay, so that's how the circuit looks like, or the block diagram looks like for the equalizer part. And for the information for each part, you already learned this in the previous labs. Okay, so for example, the filter you learned in lab 10. For the amplifier, you learned in lab 8. Okay, so basically the final project is just a combination of the previous lab. So you use what you learned in previous lab, and you use it in final project. Okay, so after you understanding the block diagram for the equalizer, we can start to talk about the schematic for the circuit. Okay, so I'm not going to draw the whole schematic. The whole schematic is in this document on the Brightspace, but I will just give you an example. Okay, so here, this circuit in here is the circuit for this part. Okay, let's draw. Okay, so this part is the circuit in here. Okay, which here this band pass filter is here. This part is the band pass filter, and this volume control is using the inverting amplifier, and this summing amplifier is this summing amplifier here. Okay, so that's how the schematic in here corresponding to each different part. Okay, let's clear off. Okay, so for the low pass filter and high pass filter, you already play in the lab 10, but the band pass filter, which is the first time you use band pass filter. So basically, the band pass filter is just a combination of low pass filter and high pass filter. Okay, so let's draw something here. So remember, the low pass filter, the magnitude response is something looks like this. And then the high pass filter, the magnitude response is something looks like this. So after you combine these two filters together, what you will have is something looks like this. Okay, because after you combine the high pass filter, you have the low pass filter, you will have something like this. Remember what I just drew. Low pass filter, high pass filter, and you combine them. Okay. This part is something looks like this. Okay, and then the bandpass filter, you have two cutoff frequency. Okay, so actually I already draw in here. So for the bandpass filter, you have two cutoff frequency. Okay, so because you have two curve, and this curve is defined by the high pass filter. Okay, remember this curve is the high pass filter, which means this cutoff frequency is which means this is the okay. So this is a high pass filter, and the value for this capacitor and the resistor is defined by this cutoff frequency. And similarly, this is this curve here is defined by low pass filter. So the cutoff frequency in here is used to calculate the RC value in here. Okay, so that's how you can calculate the RC for the bandpass filter. Okay, so after the bandpass filter, you will have the volume control for this pass, and then this is a summing amplifier for each filter. Okay, so it's actually should be drawn like this. So let's see. Okay, actually before I talk about how to calculate the resistor value, let's talk about the requirements for each for the circuit. Okay, so here here is the requirements for you to calculate the value. Okay, so for example, here is a cutoff frequency for low pass filter. So this filter should have a cutoff frequency of 320 hertz. And here is the cutoff frequency for the bandpass filter. Okay, from 320 to 3.2K. Okay, so here is 320. Here should be 3.2K. And then high pass filter, the cutoff frequency should be 3.2K hertz. Okay, so and after you do the measurement, the final result can be within 10% range. Okay, as long as you're within this range, it can be we count it right in your report. Okay, so that's the value you're going to use for the filter part. Okay, and then you're going to, after you calculate the value for the filter, you're going to calculate the value for each amplifier. Okay, so how you can calculate those values is according to those requirements. So first of all, the minima. Okay, so remember, if you check the topology document, how you can control the volume is by using the potentiometer. Okay, so when you tune the potentiometer to minima, you should have the output smaller than 15 million VRMS. Okay, and then when you tune all the potentiometer to maximum, you should have the output at 100 million VRMS. Okay, and remember those values are based on when the input is equal to 1 volt VPP. Okay, and also when you check this value, you at least need to check those three frequency. Okay, 200, 2K, and 10K hertz. Okay, and also when you do the calculation, remember this unit is VPP and this unit is VRMS. You're going to use this equation to transfer them to same unit, then you can do the calculation. Okay, so this requirement, the minimal, this requirement is easy to satisfy as long as your circuit is building correctly. So then you tune the potentiometer to minimal, you should able to satisfy this requirement. And then for the maximum, so you're going to use this requirement to calculate the value for the R4 and R9, and also for R2, R4, and R6, R8, R9, and R10, you're going to use this value to do the calculation. Okay. So this value in here is the output voltage, okay, which is the V amp at here. And how you can get the equation between V amp and V in is here. Okay. So the output, the V amp is just equal to V in times the gain for first amplifier. So let's call it gain A. And then times the gain for second amplifier, the semi amplifier. Let's call it gain B. So that's how you put the equation to calculate the resistor. Okay. So this is the first equation. Then the gain A is related to the value for our potentiometer and R4. Okay. So gain A is equal to our potentiometer divided by R4. Okay, so if you remember the inverting amplifier equation, this is the equation. And then you can think about this. Our potentiometer is the variable resistor. So in that case, the gain A has a range. Okay, start from 0, end at 10K or R4. Okay, so why? Because when you tune the potentiometer to minimal, then the output is equal to 0. So 0 divided by R4, that's just 0. And then when you tune the potentiometer to maximum, that is 10K. Okay, so that's the maximum gain you will get. So which means your gain is within this range. Okay, similarly for gain B, you're going to use 10K divided by R9. That's the gain for maximum gain for the gain B. Okay, so then you're going to plug those equation back to here. Okay, so then you can calculate the R4 and R9. And remember, this is the value, this is the condition that when all the potentiometer at maximum. So in that case, you're just plug in 10K. Okay. So after you get the calculation, okay, after you do the calculation, you will get some value for gain A get times gain B. Okay, so I'm not going to tell you the answer, but let's just give an example. So for example, you will get the result like gain A times gain B equal to, let's say, 0.8. Okay. So this is just an example, remember. So this is not the result. Okay, so I just want to give you an example. So in that case, what you can do is you can define gain A as 1, gain B as 0.8. Okay, then you can plug back to this equation. Okay, so for example, gain A equal to 1, which means R4 is just 10K. Okay, and the gain B equal to 0.8, which means let's say something R9 equal to something around 1.2, guess something around that. You can do the calculation. So that's how you do the calculation. And remember, when you define the gain for the gain A and gain B, you don't want to make this two value like too much difference. So for example, if you define gain A as 10, gain B as 0.08, so theoretically, you still satisfy this equation, okay? But in the real world, it's hard to make a amplifier that has 0.8 gain, okay? 0.08 gain. So you want to make sure the gain A and the gain B don't have too much difference, okay? So for example, 1 and 0.8, that's okay for the amplifier. Okay, so that's how you do the calculation for each resistor. So that's include. So I just gave you an example for R4 and R9. So you will use same method to calculate R2 and R8 and also R6 and R10. All right. So after you do the calculation for each resistor, you can build a circuit. Okay. And so that's how you satisfy this requirement. So this is the last requirement. So the ripple. So let's draw something. So at the end, after you build the system, you're going to plot the magnitude response. Okay, ideally, okay, so let's say this is a magnitude response for V amp. Okay, so output voltage. So ideally, when you tune all the potentiometer to maximum, okay, so let's say here is maximum, you will have a straight line, okay, something like this. Okay, let's say this is 200 hertz. This is, sorry, this is 2K hertz. And this is 10K hertz. Okay, make sure you label this 3 point. Okay, so that's what you want to check. So ideally, as I mentioned, when you tune all the potentiometer to maximum, the value in here should be about 100 milli VRMS. Okay, that's the reason how you do the calculation for each filter. Okay, and then so that's how you check your system satisfy this requirement. And then for this requirement, so as I mentioned, ideally the output will be a straight line, but it will be not, okay, because not everything in the real world is ideal. So you will have something like a straight line, but with some ripple. maybe something looks like this. So here is the maximum and here is the minimum for the magnitude response. So what you want to make sure is the minimum and the maximum and minimum, the difference between them should be smaller than 15 million VR mass. Okay, so that's the last requirement for the circuit. Okay, okay. So that's basically how you do the calculation for all the components. So after you calculate the value for each components, so before you start to build the circuit, you want to make sure the value you used, so you have those components in your lab kit. Okay, so especially if you're at home, uh, you need to make sure you have them. And if you're near the campus, you can uh, take some from the double E shop. Okay. Okay, so after you do the calculation and verify you have those components in your lab kit, you can start to build the circuit. And remember, when you build the circuit, you want to start with each individual circuit. Okay, so you don't want to build this whole system and to then you measure the final output Vamp. Most likely your it's not going to work. Okay, what you need to do is you want to start from each small part of the circuit. So for example, if I build this project, I will start with the low pass filter. Okay, so let's say, so you just test this low pass filter at very first. Okay, so you can use the network to get the magnitude response. So the low pass filter will be something looks like this, right? And you check the negative 3 dB point, which is the cutoff frequency, should be something around 320 hertz. Okay, then you verify your low pass filter is work. Then what to do next is I will test this volume control, which is the non-inverting amplifier. I mean the inverting amplifier. So what I'm going to do is I will put here as the input and put here as the output. Okay, so maybe you can put a small sine wave at the input. So I can test it by oscilloscope. Okay, so for example, let's see. So this is the input, small, let's say this a 0.1 volt sine wave. Okay, then if you define your gain for this amplifier to be 1, then what's at your output when the potentiometer at maximum will be also 0.1 volt. Okay, so this is the input, this is the output. Okay, and then you can try to tune this potentiometer. What you will see is the amplitude for the output will change when you tune the potentiometer. It will be at maximum when you tune the potentiometer to maximum, and it will be like a straight line when the potentiometer at minimum. Okay, so after you verify that, and remember when you make sure you have each individual circuit work, you take a screenshot. Okay, so for example, you test your low pass filter, you use by using magnitude response, you take a screenshot for your magnitude response, and after you verify your inverting amplifier, you take a screenshot of the oscilloscope. Okay, so in that case, even if you cannot make the whole system work at the end, you still have partial credit by make the individual circuit work. Okay, so after you do that, I mean, after you test the low pass filter and the inverting amplifier, you can combine them together. Okay, what you're going to do next is you put here as input, put here as output. You're still going to use the network to test it. Okay, so what will be looks like is still a low pass filter, and when you tune the potentiometer in here, you will see this magnitude response go up or go down by tuning the potentiometer in here. Okay, so that's how you verify these two circuits work together. Okay, so sometimes what will happen is when you test the low pass filter, it works fine, and when you test the inverting amplifier, it works fine. But when you put those two circuits together, it's not going to work. So there are a couple reasons cause this issue. The first reason is the loading issue, okay, which means, let's say, the resistor here, R1 and R2, the value for them is too close together, which causes the loading issue. Okay, so which means this filter is affects the performance of the inverting amplifier. Also, they are affect each other, which will make your circuit not work as you expect. Okay, so how you can fix them is the first way you can do is when you do the calculation, you make your R2 much greater than R1. So this will solve the loading issue. And another way to fix this is you can put a buffer in between. So before R2, you put a buffer. Okay, so remember the buffer is something looks like this. Okay, I think you learned this in lab 8 or lab 10. In the pre-lab, you build the buffer. So remember the buffer is help you to separate the circuit. And then this should also work. So if you don't want to change the value for R1 or R2, you can put a buffer in between. Okay. So that's how you test each individual circuit. Okay. And then you can also test so you can use the same method to test the band pass filter and also the high pass filter. And for the summing amplifier, okay, so there's another way to test it. So the summing amplifier looks something like this. Okay. You have, I think you have 3 paths. Okay. Sorry, my drawing on the computer looks not good. But anyway, so for example, the summing amplifier here, you have 3 input. Okay, you have 1 output. So what you can do to test it is, you can use, since you're using AD2, you only have um, two output. So two function generators. So you can just test either two of them. So for example, you can put a sine wave as this input. Okay, so let's say a 100 hertz sine wave. And then you can put a 2 kHz triangle wave as this input. Okay, so then what the output looks like will be a combination of triangle wave and sine wave. Maybe it will be something. This one is. Okay, you can see here is a combination of sine wave and triangle wave. It's the small frequency is still the sine wave, and the larger frequency is the triangle wave. So, and then when you tune the potentiometer here, you will see the magnitude, the amplitude increase or decrease by tuning the potentiometer. So that's how you can test the summing amplifier. And if you check the requirement here to test the 6B here, test the adder. So the adder is just the summing amplifier. Okay. Okay, so that's how you test the each individual circuit before you build the whole system. So after you test each individual circuit and make sure they all work individually, then you can combine the circuit together to plot the Vamp. Okay, so that's the final result or the final output for this whole system. So that's what I mentioned. You're going to use the, let's see, the magnitude response. Okay, put here as input. So here is Vin, and put here as output Vamp, which is Vamp and Vin. And then you plot the output. Okay, so let's say try to maybe start from 10 hertz. Okay, start from 10 hertz and end at, let's say, 20 kilohertz. Okay, and the requirement is here is 200, 2K, and 10K. So this range is the range of this three frequency. Okay, so ideally, when you, as I mentioned, when you tune all the potentiometer to maximum, okay, the maximum should be 100 million VRMS. And when you tune the potentiometer to minimum, the minimum will be less than 15 million VRMS. And also, you need to take another screenshot that when the volume is in medium. Okay, so somewhere in between. Okay, so that's the screenshot for this part. Okay, and also, actually this part I already mentioned, but I just go this part again. So the screenshot you need to include in your lab report. Okay, first of all, the magnitude response for each filter. Okay, so as I mentioned, when you test each individual circuit, you want to make sure you have a screenshot. Okay, also you have a screenshot for summing amplifier, and then you have a screenshot for volume control. So each inverting amplifier, you need to show it work. So as since each inverting amplifier, they work in same function, so you want to make sure you just show one of them is working. We will assume other two is working properly. And this one is uh, the Vamp. And the last one, you want to show the ripple. Okay, so for example, after you get the Vamp at maximum, you want to zoom in this part. Okay, you zoom in this part so we can clearly see your ripple, and you can measure the minimum and the maximum. The ripple should be within this range. Okay, so that's the screenshot you need to put in your uh, federal report. Okay, and that's actually already mentioned in this document. Okay, so you can either use this document to take a screenshot, or you can use the things I write in here to take a screenshot. All right. And lastly, I think some students are confused about this question. Okay, remember when you do when you write the report, you need to answer all of those questions. Okay, so this question is asking about the power amplifier. Okay, which is the LM3A6. So to answer those questions, you need to check the data sheet. Okay, the data sheet for this component. Okay, so that's number 3. Okay, I think that's all for the final project. Just remember the deadline for the report is end of this Sunday. Okay, so it's less than 1 week. So as I mentioned, it's kind of like a short time. So you need to start early. Just don't wait until the last day. Okay. Right. So that's all for the project. If you have any question, you can email me. And lastly, I want to talk about the the lab practical really quick. Okay, so I'm not going to talk about the whole test. I just talk about there's a common mistake for the lab practical. So this question, I think this is some of the students make a mistake in this question. Okay, so how you can calculate the value for R top, R bottom, and the V source. Okay, so those are the three equations you're going to use. First of all, you know you're using the potentiometer, so you know the maximum value or the total resistance is 10K. So R top plus R bottom should be 10K. And then remember the RTH. So if you remember this in the lab fab, you already play with this equation or play with this kind of circuit. Okay, so which means that the RTH is actually equal to R top in parallel with R bottom. Okay, so you're going to use this is the second equation you're going to use. Then the third equation is this one. Okay, so this is a voltage divider or voltage division circuit equation. Okay, so the uh, the V source times R bottom divided by the total resistance is the output voltage I here. Okay, so this is output voltage. So overall, you have these three equation. You have three variable. You can have the answer. Okay. Right. So that's how you do the calculation for this question. And then for the next step, so this is the first task in the in-lab portion. Okay, so when you build the circuit to test the output, the open voltage and also the short circuit current. So this is the circuit to test the open voltage or the output voltage. Okay, so the voltage I here is just the output voltage. And then I think most of students get this part right. But some of students get this part right. Get this part wrong. When you test the short circuit current, you want short this output to ground. Okay, then the current goes through this part is the short circuit current. And similarly, that's how you do the measurement on the breadboard. Okay, I think this is just the common mistake in the lab practical. So I just give you a quick answer for this question in case you wonder. And also, if you have any other question for your lab practical, you can just email me. Okay, I think that's all for today. Just start your project early. Okay, don't wait until the last day. Okay.